My name is Johann van Biljon. We're going to show you the 6-part series of restoration that we do on the river systems. It's called Riparian Restoration, so riparian just means rivers, and hopefully you'll find insight into it. We realized through making this video, this is a world that a lot of people are it's foreign to a lot of people. So just hang on to it. There will be some concepts that you maybe not going to grasp initially, but just keep on looking, and hopefully it will be explained through the rest of it. If it isn't, find out details, send the email, send the WhatsApp, whatever is needed, and then we'll explain to you in more detail. The river systems have been badly degraded in my lifetime. I realized that some of the streams that I saw as a kid, I won't let my kids play there anymore. And it's going on a downward trend, and that can be changed if we are willing to pay the price.
Intaba Environmental Services specializes in restoration of degraded ecosystems. Our goal is to make conservation practical. For our digital field trip, we will be taking you on a journey introducing you to some of the role players, experts, and sites we're currently involved with, as well as providing an insight into some of the valuable lessons learned along the way. We are based in South Africa in the Western Cape and predominantly focuses on the Berg and Breda catchment areas. Our field trip will be comprised of 6 short videos covering an introduction to the Berg and Breda catchment areas, plant propagation, palmeet, research conducted, community, and a conclusion.
This project lies in the Cape Floristic region at the southwesternmost tip of the African continent. This is by far the smallest of the world's floristic regions, compared to the whole Arctic, for example, which occupies most of the landmass of the entire northern hemisphere. Within about 90,000 square kilometers is found over 9,000 species of plants, over 70% of which are endemic, meaning they only grow here and nowhere else in the world. This makes it by far the most species-dense vegetation type in the world. A component, and the most threatened component of this vegetation type, is a Mediterranean type scrub known affectionately by locals as fynbos. Part of this vegetation type's incredible diversity stems from diversity of the landscape in which it finds itself. From oceans to mountain peaks over 2,300 meters in elevation, and soils ranging from sandy through pebbly to shales and clays. The variety of soils combined with the sheer bulk of the mountains creates unique microhabitats based on aspect, exposure to or protection from prevailing winds, and a range of precipitation extremes from less than 250 millimeters to over 3,000 millimeters per year in some places, the bulk of which falls during the cold winter months. The converse of these wet winter months is dry summers, which encourage a periodic fire cycle of around 15 years for a given area. And all the typical fynbos vegetation is geared towards a variety of fire disturbance responses, including mosaics of resprouters versus reseeders, and an incredible diversity of seed dispersal adaptations designed to avoid the heat of the fire, whilst relying on its cues to trigger germination once the danger has passed but the landscape cleared of competition. This project is focused on the upper reaches of the Berg and Breda rivers, both of which are considered strategic water sources for the area, in particular for agriculture and the large urban centres, most notably the city of Cape Town metropolitan. These rivers would or should be representative of fynbos, riparian scrub fynbos, and afromontane vegetation units, depending mainly on their protection from fires over the long term. Each of these would consist naturally of multi-species complexes with shrubs and trees and herbaceous components, and would also include the ecologically significant endemic water plant called palmeet. Often referred to as a reed, which it is not, this plant is an obligate wetland and riparian species which is resistant to the high water flows that accompany the frequent seasonal flooding of the Riparian Zone following heavy frontal downpours in winter. This context should go a long way to explaining how difficult it is to undertake a rehabilitation project in this area. One must balance the need to re-establish multi-species complexes within this backdrop of a high degree of endemism, and the fact that some species will exhibit extreme range or habitat preferences. The need to source local propagules from the immediate area of the rehabilitation site is paramount to avoid genetic pollution of the gene pool. Add to this the backdrop of complexities of soil changes due to agricultural disturbance from either plows or cattle, and chemical disturbance through the same agricultural practices, chemical changes in the water, but also the backdrop of the original invasive species that was cleared and its effects on the soil and the hydrology of the area, as well as the compounding effect of the potential secondary invasions that can occur after initial clearing. And you'll appreciate that vegetative rehabilitation in this area is a botanical tightrope walk.
As per the State of the Rivers report of September 2019, around 65% of the Berg River and even more of the Breda is under agricultural use. Both these systems flow through several developed urban areas and has large riparian areas cleared for both agricultural as well as social development. As a result, these river systems are largely modified. From 2005, an escalated effort was made to clear alien vegetation in these catchments, with the building of the Berg River Dam one of the main driving forces behind this initiative. 70% of the initial clearing has already been done to date. Unfortunately, not all alien vegetation cleared led to rehabilitation and restoration of these heavily modified systems. These are but two of the multiple degradation drivers on the Berg and Breda system.
So there are various degradation drivers in riparian systems, and one of the most important is invasion by alien trees. So species such as black wattle, Acacia mearnsii, and red river gum, Eucalyptus camaldulensis, were planted for reasons of timber production or firewood or ornamental and various other things. And these species have established well and then adapted to the local system and spread, and actually suppressed the fynbos riparian scrub vegetation so that they become almost monoculture stands. And this has affected negatively biodiversity and ecosystem processes, as well as ecosystem services. So the change happens in ecosystem drivers. For instance, riparian vegetation is adapted to fire and requires fire to regenerate. But once the vegetation becomes dominated by the trees, you have a change in fuel loads, and fire properties change, so that you have very severe fires. And this further negatively impacts the fynbos riparian scrub and causes more degraded area for the invasions to take over. These alien trees also impact on the hydrological system, which is very important in shaping riparian and aquatic communities, because they use more water and they reduce the flows in the river. They also affect geomorphology, which can be through the loss of wetbank plant communities, which results in increased erosion and sedimentation in the rivers, and this negatively affects biodiversity and ecosystem services as well. So altogether, aliens can affect the quality and quantity of water, and also the ability of the ecosystem to mitigate floods and droughts. Another degradation driver is impoundments for water supply and water abstraction for agriculture. Once again, this can affect hydrology and geomorphological drivers in riparian systems. It mainly is important in the foothill and lowland river reaches though, and here it negatively impacts on riparian and aquatic biodiversity. A third degradation driver is agriculture, and this is, again, it's more in the lowland areas, particularly the valley bottom wetlands of rivers, where the soils are more fertile and they're used for crop production. This causes direct loss of habitat through ploughing, and with that you get increased erosion and sedimentation. And if these agricultural fields are ploughed in the lowlands where there's surrounding agricultural land, it obviously eliminates one of the most important drivers, which is fire, because the wildfires can't get through the agricultural lands.
The Berg River today is very different to what it must have been like under natural conditions. It's a hard-working river, and it's been impacted by large-scale abstraction to support agriculture and also to provide domestic water supplies to many of the urban areas in the vicinity. River water quality has been impacted on by irrigation return flows and runoff from polluted urban areas, and the flow regime has also been changed by summer irrigation flow releases, which alter the natural regime. This, coupled with intensive development into the floodplains, has resulted in large-scale geomorphological changes, and with it a change in river structure and function. To understand these changes, we need to look at how they used to function under natural conditions. Let's focus on the middle reaches, which are generally more accessible and useful to humans, and thus most impacted. This is a winter rainfall area, and its rivers would have flowed full and fast for much of the wet season, overtopping onto broad floodplains. With the development of floodplains for agriculture, flood protection berms were constructed along riverbanks. These cut off secondary channels, and outside of really large floods, confined high flows to single, often straightened channels. Divorced from their floodplains, these fast-flowing waters cut down into the channel, deepening it and contributing to a cycle of further flood containment and channel incision. We can see the results in the Berg River, where the low-flow channel lies at the bottom of steep incised banks. During floods, river level rises vertically rather than spreading out across the floodplain. This presents a challenge for river rehabilitation, with plants either being drowned in high-flow conditions or being too dry on the top of the bank. Eucalypts and other aliens along the riverbank exacerbate summer dryness and flood confinement and can contribute to erosion through debris dam formation during floods. So the biggest drivers of change in these systems have been changes in the hydrological regime, as well as extensive floodplain encroachment and efforts to contain and manage flows, which set off a cycle of channel deepening. Other changes are more subtle, such as the loss of natural disturbance cycles, such as grazing and trampling by large mammals.
What we need to do once an ecosystem is degraded is to repair it, and the type of intervention will depend on, firstly, the position in the landscape, whether it's in the mountain streams or in the lowlands, and also the degree of degradation that has occurred. So this will determine whether we are trying to restore the area, and that is aiming to return not only the ecosystem processes but also the composition of the communities, or whether we just want to rehabilitate and improve the ecosystem functioning of that stretch of river. It also will determine whether we are aiming for active restoration by reintroducing all the elements, or whether we're relying on passive restoration. Passive restoration means removing the degradation driver and allowing the system to spontaneously recover. What research has shown is that in the mountain stream and foothill reaches, where invasions are the only impact, removal of the aliens can allow recovery in over 80% of cases through spontaneous succession. But it's important to use a clearing method that removes the biomass from the riparian zone, so that you prevent subsequent severe wildfires from occurring. If there are other or degradation drivers operating, such as abstraction or impoundments, one cannot remove that degradation driver, and so it may be more appropriate to rehabilitate. In other words, try to improve functioning, but it's going to be unlikely that you will be able to restore the historical ecosystem. So in lower reaches, where the riparian zones are isolated from natural vegetation and fires no longer operate, or upstream impoundments have been impacting the flows, rehabilitation is the appropriate goal. In this case, one can still use and reintroduce the suitable indigenous species that will promote the ecosystem functioning.
These are the issues that have to be confronted in affecting river rehabilitation. They both highlight the fact that passive rehabilitation is unlikely to work, but also that rehabilitation along some systems may never approach restoration to natural conditions, but should rather focus on simply improving resilience.
I'm really encouraged to see how things have changed in the last couple of years. I've been involved with restoration for over 15 years, and initially it was a foreign concept, but now it seems to have become a buzzword. But I am a bit concerned that it's not becoming a buzzing industry. There's amazing work being done with the clearing of invasive plants, but less than 4% of the budget is allocated for active restoration. That means that 96% is left for passive restoration to take its course. This is concerning in light that we are putting a lot of emphasis on the degraded systems to restore.
In these badly degraded areas that are isolated from the intact functioning systems, they will most likely be reinfested by secondary invasions. Then these systems become even more modified and are dysfunctional. These are the ecosystems that we are dependent on for our most basic existence, water. Neglect will have devastating effects on an already stressed social and economic future. Role players that are involved in the riparian rehabilitation on the Berg and Breda River systems are the funders, which are mostly government-based, Department of Environmental Affairs and Development Planning, Department of Agriculture, Division of Land Care, SANBI, the South African Biodiversity Institute, and the Public Works Department. Funds for labour are channeled through national level and is called EPWP, Job Creation. There are other private funders such as the FSC, Reforest Action, biomass companies. The land where the rehabilitation is occurring is mostly on private land. Farmers are the custodians of this land and have an active role in managing the rehab site, for example, provision of irrigation. The service providers are the organizations and companies that undertake the rehabilitation. Working for Water is a government-based organization that undertakes alien clearing, while Intaba is a private company that grows plants for rehabilitation purposes and plants them along the rivers. There's also other companies, such as the African Biomass Company, that undertakes some rehabilitation services. Researchers include Intaba, research institutions such as Stellenbosch University and the University of Cape Town, postgraduates and academics. We are attempting to ultimately generate peer-reviewed work to allow lessons to be shared with others. Other role players include civil organisations, namely the Wolseley Water Users Association, Breda Kloof Wine and Tourism, as well as conservancies in these areas. Some private companies, namely Living Lands, also assisted with workshopping opportunities.
My name is Dean Hill. I'm the General Manager of Rhodes Food Group here in Tulbagh, and I've been asked just to share a little bit about the river restoration project and kind of what the process is, so how do you get in touch with somebody, how do you negotiate, what's the process? And so being in the Tulbagh community, we got to know Taba, and we could immediately see value, see how you could partnership and have a fantastic river restoration project. And you know that it's not going to be for this year or next year, you'll start seeing it over time, and you're building a legacy. So Rhodes Food Group wants to build a legacy of a beautiful river where we protect our water source and build something beautiful for the future. And the first step that happens is that, we need to negotiate about who's responsible for what. And I think the whole thing is about that you've got people passionate about river restoration and you've got a business. And how do the two come together? And for us, it's about water. This is the river that we get our factory water from. And if we can protect it, we protect the water along our section of river, and it's for us and for the people downstream and for our next generation. And the first thing is about seeing, okay, Rhodes, you look after the irrigation. We will pay for it, and then Intaba helped install it and put all the drippers in the right places, and the irrigation to make sure that we manage to get the plants from a very small seedling stage up to a stage where they can survive without irrigation. Probably a 2 to 3 year process. And the second thing is about, at the beginning there was lots of alien vegetation, and so we had to clear that out. Going into the future, Rhodes will take over the maintenance of the site. So, we'll make sure that we keep the aliens out. So it's all about a partnership. One of the challenges that we had on the site was that there was an existing herd of cattle that the Rhodes pensioners use this land for. And obviously with small plants, cattle are going to be detrimental to the seedlings. So we had to put up a fence around the area, and Johann from Intaba had to talk to the cattle owners to explain to them about why the fence is there and what we want to create, to get buy-in from them as well. And that's one of the challenges that we've had on this particular site is multiple land uses. I think one of the big focus points of businesses nowadays in the listed environment is definitely sustainability. And every month Rhodes Food Group measures how much water we use, how much coal we burn, how much electricity we use. And I think that projects like this will become part of the DNA of businesses going into the future. As a business with huge resources, how do we give back to the planet? And I think that, you know, in the Western Cape, there's people looking at wood burners instead of coal from Johannesburg, and you know, these sorts of projects should be projects that, you know, we could use to help our sustainability goals as a business. And I think that water, the scarcity of water, you know, talk about the next world war is going to be about water, and how much more can we give than doing river restoration? You know, we directly affecting the quality of water that we have available to us all.